Well, hello, Financial Lit. We are going to talk about continuous compounding. I posted a video that kind of shows you how it works and how we derive or get to E, that number, that Euler's number. So we are just going to be using E as a base. It's a number, just like pi is a number. Okay, come on. There we go. So again, E is just a number. It equals Andrew Jackson. The way that I remember this is that Andrew Jackson is our seventh. I actually have this all memorized. Andrew Jackson is our seventh president, and the people elected him in 1828, and they loved him so much they elected him again. So 1828. And he was a wonderful mathematician, and he knew how to solve a 45, 90, 45 degree triangle, and he loved his wife so much he married her twice. So all of that to say that E equals 2.718281828 45, 90, 45. I will tell you I've had this memorized for years and I've never used it except for when I talk about it. You can just use E on your calculator or E in, yeah, see, I really do have it memorized. Or you can just use it in your E in Desmos. You don't need to have it memorized. You just need to know that it represents a number and it's not a variable. So it is kind of like I is a number, it's the square root of -1. E is a number, it's 2.71828182845, and it goes on more than that. Pi is a number, 3.14, so that kind of a thing. Okay, so this is our newest formula, and it is for continuous compounding. So we're going to go through this. Make sure you get that in your notes. All right, so we are going to use it. So if you deposit $1,000, so our principal is $1,000. And our interest, our E is going to be equal to E because it's continuously compounded. So that's what we're looking for. So we know what formula we're using. Our interest rate is going to be 0.023, and we are looking for the balance after 5 years. So then we just plug everything in. So we have 1,000 times E to the 0.23 or 0.023 times 5. So we are going to type that in our calculator. So if we go to, I'm going to use my calculator to show you how it works. We'll turn it on. Oh man, I just had it up. Sorry, let me get it up real quick. Okay, so we have 1,000 times, so second, my division sign will give me E. I'm going to use my caret, which is right here, and then I'm going to put 0.023 times 5. And I am going to get $1,121.87. I know that because I'm rounding to the nearest cent. So that is what we are going to put. So our answer, our ending balance after 5 years would be $1,121.87. So that's our ending balance. All right, we're going to try this again. So I'm going to again put P is equal to 5,000. My E is equal to E. Oops. So we have my P is equal to 5,000 because I'm using the same formula because it's compounded continuously. My E is equal to E. My R is equal to 0.0112. My T is 4, and I'm going to plug all of that in. Times 4. Alright, so let's plug that into our calculator. So I'll pull that up. So we have got 5,000 times E raised to the 0.0112 times 4. And I get $5,229.09. So that is going to be our answer. So I'm going to put $5,229.09. Okay, we're going to do this one. So if we deposit $7,500, so oops, yeah, there we go. So we have our P is equal to 7,500. We have our E is equal to E, compounded continuously. That's how I know that I'm not using my compound interest formula. We are going to say our rate is 0.0315, and my time is equal to 7. So go ahead and put that in your notes, see if you get the same answer as me, and let's check. Okay, so you should have your equation set up this way, and we should have this in our calculator, 7,500 E raised to the 0.0, and we should have gotten, I don't know why that is doing that, but we should have gotten $9,350.25. Because remember, we want to round to the nearest zero. So it's 25 cents. So we've got 9,350 and 25 cents. All right. So this one, we're going to kind of work a little differently. So we're going to solve for time, because this is saying how long. So I'm going to be using the compounded continuous formula and to figure out how long it would take to get the balance. So if you deposit, so my P is 3,500, and my E is still going to be E, and my rate is going to be 0.0115, and my time is a question mark, but I know what my ending balance is. It's going to be $7,000. So I'm going to set this up. Now this should look like solving for time the same way it did for compound interest. So what we're going to do first is we want to get that all by itself. So we're going to divide by 3,500. And we get 2 is equal to e to the 0.0115 times t. Now we can use those basic log rules because we're solving for an exponent. And remember, we said that log, 3 log of x is equal to x to the third power. So we know that. So if we know that, we can use that. So I'm going to take log of 2. I'm going to take 0.0115 t times log e. Now it's just like it was. I got to get this by itself. So I'm going to divide by log e, divide by log e. And of course, I'm out of space. Sorry. So then we end up with log 2 divided by log e is going to be equal to 0.0115 t. This is just a number. I don't know what the number is. It's probably a decimal of some sort. So let's figure that out. Let's go over to the calculator. And I gotta figure out how to erase this. Okay, so we have log 2 divided by log e, and we get that number. So 0.693, and then we need to get, if we're looking, we need to get this number, we need to get the t by itself, so we're going to divide by 0.0115, that becomes a 1, but then we're going to divide this by 0.0115, and if we do that in our calculator, then we end up with that answer divided by 0.115, and we get t is equal to 60.3 years. So it's going to be 60.3 years if we were to compound continuously this amount of money at this interest rate to double our money to get to 7,000. All right, so if you have any questions, please ask me in class. Otherwise, you have this. This will help you with 2.9b. That whole worksheet is based on this. So let me know if you have any questions. Otherwise, I'll see you in class.